Welcome to ClickMyProject.com. Now we discuss about the product for a novel two-split capacitor array with linearity analysis for high-resolution SAR ADCs. Next we see the abstract for the product. Recently the successive approximation register analog to digital converter has attracted more attention again for that it features low power and area consumption due to its simple structure and least usage of analog circuit. This it's used to widely in today system on a chip solutions where requires low power and low cost and high speed and high density. As we all know, capacitor array DAC is used to popularity in SAR ADCs. For a binary weighted capacitor array, as the resolution increase, a problem comes up. The total number of capacitors in capacitor DAC will has the exponential increases. This will lead to increased chip area and power dissipation as well as reducing speed to large charging time constant. Obviously it does not match case of SOC's requirement. To mitigate this problem, unsplit capacitor array is used to which can reduce total number of problems still exists and cannot be ignored. This paper presents a novel two-split capacitor array structure based on conventional capacitor array. When used as digital to analog converter, this circuit reduces the chip area with the conventional split capacitor array methodology. A novel two-split capacitor array structure for successive approximation register analog digital converter is proposed. When used to digital to analog conversion, the circuit reduces the chip area and the power consumption. In comparing to conventional split capacitor array, to improve the resolution size, the area reduction effective to more significant with increasing the resolution of ADC. The capacitor mismatch and parallelistic effect the proposed structure are analyzed in the theory. Behavior simulation were performed to demonstrate the effectiveness of the proposed structure. This simulation was only performed for capacitor mismatch, and simulation results show in the T-split capacitor array to achieve the good binary weighted elements for overall architecture. Next we see the flow diagram for the processor. First we apply the analog input signal to passing to the sample and hold signal. Sample and hold events based on the time period and to split the sample and section and hold section for continuous periodic signal. Then the continuous periodic sample and hold signal to apply to the comparator architecture. We use the pulsar latched based comparating CMOS design to apply the comparator architecture. This design to reduce the power consumption and to analyze the voltage difference effectively. This architecture to reduce the overall die size for our comparating performance area. Then to passing the SAR logic operation. The SAR logic operation full and full present the D register element for every signaled output data register architecture. This architecture passing to shifting element for our required data shifting process for overall D register element architecture. This architecture to apply the feedback signal to the two-split capacitor array based DAC signal. The DAC signal to arrange the how many bits to be presented in our overall SAR logic presentations. We update the 14-point DAC signal for our required architecture. So we apply the 14 selection signal and the V reference and ground terminal to connected to the two input of the MUX architecture, and every time we select the SAR output and to select the ground or set 1 to passing the voltage reference or 0 to passing the ground reference to be passing and the two-split capacitor array event. These capacitor array events mainly used to reduce the leakage power of DAC sections, because DAC section is presented in the feedback element based architecture, so the feedback wise voltage dropping presented in many more times. So we update the voltage losses between the leakage power. So we focused the capacitor array to maintain the voltage for temporary storage purpose, and every segment to 14-bit elements to split into 3 sections, and each section to be connected in the parallel form of capacitor array and to arrange the serial form of capacitor array for overall 2 split capacitor array based DAC sections for our required modification in that block diagram, and to passing the voltage reference output to the differential amplifier. This amplifier to amplifies the output and to one of the input to be passing to the comparating element. Comparating element based on these two functions and to produce the reference digitalized output for the SAR logic function. Successive approximation register to store the events and to get it to the final data output for the required analog based digital sampled output for the processing. This is the overall flow diagram for our CMOS oriented based SAR based ADC architecture designs. Finally, we designed the SAR ADC based CMOS designs oriented process. This process includes the SAR function and ADC and DAC block for overall architecture functions. These are the Tanner model designs. And to designs open the cell 7 for these are the block design for overall CMOS design based process. These are the final design. These are the overall CMOS design for required and SAR block and the ADC block and based on the flow diagram CMOS designs oriented process, and to produce the and to apply the analog input signal and to produce the digitalized samples for overall architecture functions. Then to run the cell 7 design. This design to run and produce the output for the ADC functionality for required output based process. Is the running output for overall CMOS based blocks designs oriented work output. This output represents the analog input and the digitalized output samples for required output functionality. These are the final simulation output for the overall ADC functions. These are the applied input signal and these are the required digitalized output signal. These are the sampling holding signal. This comparating output. These are the DAC function output. These are the final output for overall SAR ADC based CMOS designs. Just to split the any other things and to run the any one of the analog input output to split into the continuous periodic samples for our sample and hold event. Then to passing the comparating one of the input and another one input to produce the digitalized output for SAR ADC feedback signal output, and to produce the comparating output for the our output signal. This sample signal to produce the digitalized output for our overall architecture. This output represents the final digital output for based on these periodic sample in analog input signal, required analog input signal. These are the overall final output for our SAR ADC function CMOS designs based process.